The CMM machine, or the actual name is the Coordination Measurement Machine. It does have multiple shapes and arrangement. One of these shapes is the one we have in the front of us, which we call it the cantilever arrangement. It's cantilever, moving to the left and right, and this one is going forward and backward, and thus it can provide the two-dimensional movement. This will be the x-axis value, and this will be the y-axis value. The probe itself is going to go up and down, and this can give you the value for the z height. So what you can see in the screen here, actually the screen cannot be moved unfortunately. We can see the x and the y value mainly because this machine is mostly can do the two-dimensional measurement. More advanced machine like the one we have there can do the 3 dimensions. If I get to put the probe there, I'm going to take the photo for you and show it. So the options we have here is available for us on this screen. Again, to put the camera as close as possible. So usually you start with doing the measurement. We are going to have the list here. We're going to select from it, and we're going to start to do the measurement process. The measurement we can have is check the point location in the space, the midpoint between 2 points, the point to the center line, line to line distance, circle diameter, line, the spherical shape, and the PCD. So we start with the circle. For circle we can have the internal diameter, the outer diameter, and I'm going to choose the internal diameter. The number of the points can be set up. I will choose the number to be 6, and I'm going to tell you what are these numbers referring to. Finishing with the selection, pressing yes again. Now we can simply do the calculation for the internal diameter by pressing measurement. As we do the pressing of the measurement, you can see that the probe is start to flashing. That means that the probe is ready to measure. This is a probe we have. This probe can have the ruby sphere at the end. This ruby sphere is too sensitive. It's going to be discharging the electrical current we have in this probe to the metal, to the part we're going to be in touch with it. Actually, it didn't do it for my hand. It did it for my hand. Actually, it just did the first measurement because my hand is conductive and did the reading. I'm going to repeat the process again because I don't want to have this reading. So I will say yes, 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 measure, and touch it for multiple times. So you can see that even if I'm going to touch multiple locations, it's going to do the same process. 2 more readings, 1 more reading, and done. So it's just give me the coordination diameter is 0 because we didn't move the probe anywhere. Now what I need to do is I need to take the probe down, and this approach actually is quite tricky because this probe is quite heavy, and any wrong movement can drop it down and break the probe. Actually, in my time at the UTS, I broke the probe 3 times. This can be happened by release this lever down here and then try to take the probe somewhere just below the surface side. So just checking that. Now, yes, it's touching the thing. I'll take it a little bit more. Yep, now it's fixed. Okay, now I'm going to start the measurement process again. So again, the process is going to be done by pressing for the measurement process. Check the measurement to be for the circle. For the circle, I'm going to choose the internal diameter, and I choose 6 points. Press measure. So yes, press measure. Okay, now you can see the movement of the probe. I'm going to move the probe slowly until I'm going to touch the ball. I got first touch. Now I'm going to have another 5 readings to be measured. Say measure. I'm going to move it to the other side. for measure. I need to distribute the location of the point of the measurement to a different location in the circle. So what's happening here is that the device is going to do the circle by approximating the diameters and then check the average and give it to you right here. Another 2 points to go. Measure. I'm going to choose two opposite points, this one and the one on the other side. Okay, then I got the reading. Now you can see the reading we have here is 38.014. The reading we had on the height gauge was 40.0 something. Now we had this difference because in this machine we don't compensate the diameter of the probe itself. That's something we need to add by ourselves. So this probe have 1 millimeter radius. So 1 millimeter from each side. That means we need to add 2 millimeters to the diameter of the circle we just measured to have the actual diameter of the circle. Now I need to put this one down because otherwise it's not going to be safe. And this is it. Now, as I told you that the more advanced one, I'm going to bring my laptop and walk around in the lab. The most advanced CMM machine is the one which can be moving by program. Okay, now this is another CMM machine. This is more advanced. You can see that it have the tower shape, and once again this will be the x-axis, this will be the y-axis, and the probe here is going up and down, as you can see here from the top, and this will be the z-axis. It can check the location of the point on this spot. The probes are there. This can be changed automatically from the machine. The head we have right now is 3D scanner. Unfortunately, this machine is not operating at the moment. Otherwise, I was more than happy to demonstrate that for you. So what's happening here, it's something like we're teaching the machine to read the part as a Braille method. So it's going to touch the part in multiple locations and check if the coordination is going to be compatible with the one we learned the machine to move it to. So the probe will touch this point, for example, or check the thickness of this part, or the length of that part, or the height of this point, or the diameters here. And compared to the CAD model, we ask the machine to read first. So we give it the coordination, and it's going to check the coordination on the actual part and tell you if this part is compatible with the CAD model or not. That's what we call the CMM machine. And this was, I told you once again, from Nikon, is one of the most advanced one we have in our lab. But the problem we have is that the license has been expired. We are about to update it soon. Thank you very much, and hope to see you in other sessions.